Yeah, so let's do this. So you can convert moles to mass using a formula mass. And the way you calculate the formula mass is you add up the atomic masses of each of the constituent elements. So if you look at the periodic table, usually you'll find that there's an atomic mass below each of the elements. So in our formula, this phosphoric acid formula, we have hydrogen. Hydrogen has an atomic mass of 1.0079. So when I read that number, I think grams per mole. Those are the units I think about. So if I have a mole of hydrogen atoms, I would have 1.008 grams of hydrogen. So I'll write that down. I will also write the atomic mass of phosphorus down. It's 30.97 something. And I'll also write the atomic mass of oxygen down, 15.99 something. So I need to also know how many of each substituent element is in the formula. So if I look at phosphoric acid, I see that there are 3 hydrogens. There is 1 phosphorus, that's what the lack of a subscript after it means. And there are 4 oxygens. So if I multiply the number of hydrogens times the mass of hydrogens, that'll tell me how much mass comes from the hydrogens. If I multiply the number of phosphoruses times the mass of each phosphorus, that tells me how much mass comes from all the phosphoruses. And if I want to get the number, or I guess the total mass of oxygens, I would multiply the count of the oxygens times the atomic mass for each oxygen. So I've just multiplied the atomic mass times the count for each of the different elements. And then I add those up, and I get that the overall atomic mass of phosphoric acid is 97.99 grams per mole. Now, if that's grams per mole, I can use that formula as a conversion factor, and I can then convert this number of moles to grams. So we just calculated that 1 mole of phosphoric acid equals 97.9937 grams. I'll round this at the end. This isn't in sig figs, obviously. So I can use this to create a conversion factor. I could either multiply, well, I get the right tool. I could either multiply by 1 mole over 97.99 grams, or I could multiply by 99.9937 grams over 1 mole. What do you think the conversion factor should be? So I want to cancel out the moles, so that means that I'm going to use the conversion factor where this goes on top, and where I don't blank out the screen when I do it. There we go. And I want moles in the bottom because I want the moles to cancel. So that is how I would use the formula mass to get the right units, and using this as, or using unit conversion to solve this problem for me. And I end up, so if you do the unit conversion, you end up getting this number of grams, and we need to go back to sig figs before we're done. But that's what the calculator spits out, or what Excel spits out raw. And if I look at my initial number, I have 3 sig figs. And for me to round this, I would actually have to round to like that. So I'd need to get like 120 dot or something. And this means I'm going to have to do, so if I rounded it to that digit, I would get 120, like 1200. But I can't stop there because, as written, this thing only has 2 sig figs. So I'm going to have to use scientific notation to manipulate this. So I'll move the decimal over 3 places, and I'll get 1.20. This gives me 3 sig figs. Hooray. And since I moved it over 3 decimal places, I made it smaller by 3 factors of 10. I have to have times 10 to the 3rd so that the value stays the same. The units are still grams, and that would be the answer. So this is the unit conversion method for converting mass to mole, or sorry, converting moles to mass, I could actually use a formula to do the same thing. If you want to just make sure that you have lots of ways to do this problem so that if you're confronted on a test you don't freak out if you forget one of them, you could use the following formula. Mass equals moles times formula mass, and what you would end up doing is multiplying this number, 12.1 moles, times the formula mass of 97.9937 grams per mole. So this is the mass portion of it, and this is the formula mass portion of it. Formula mass. And again, the units should cancel out regardless of how you do it, and you'll end up with the same answer. Let me color code it so that I'm extra clear. If I have, wow, that did not color code. Here we go. That would be the mass. Sorry, did I write mass? Sorry, it should be moles, right? That's moles, guys. You're supposed to correct me on this. Moles. Yeah, and that's formula mass. Here we go. And this part's moles. So I can actually produce a series of equations based on this. So if I wanted to, I could actually manipulate this equation and solve for each of the 3 different inputs to this relationship. So mass equals moles times formula mass. Moles equals mass divided by formula mass. Formula mass equals mass divided by moles. And if you're using these, you know you're using them correctly if the units cancel out. So you can use the unit conversion method, the units will cancel out, or you can use these formulas to get them in the right order if you want. But again, the units have to cancel out, or otherwise you're doing something weird. Remember that mass is going to be in units of like grams or kilograms or something. Formula mass is going to be in units of grams per mole, and moles are going to be in units of counting or moles.